So this is the overall content in the information theory. I would like to cover the discrete messages, amount of information and its properties, average information, that is entropy, and entropy and its properties, and what is the information rate, and memoryless channel, discrete memoryless channel, and mutual information and its properties. So in the information theory, as we know very well that in the data transmission in digital communications, we are sending the binary data with the help of some modulation techniques over a channel. So the transmitter to receiver, that we are going to send the communication. So the binary data through digital modulations. So digital communication, that we have so many advantages so far we discussed. So the amount of data and what is the data rate that is being transmitted, that's all discussed elsewhere. And at the receiver, we are receiving some amount of data. So the messages which are being modulated and transmitted over a channel and received at the receiver, that is having some amount of data. So that entire data is not called as an information. So the information is something else. It's not directly the amount of data. Data is different and information is different. So for example, what is the information that we understand? So based on the source, the source, discrete source is generating some alphabets or symbols or some messages. Okay, that is being generated or emitted by the source. Now then we have some data, we have some messages or source symbol or alphabets. For example, there are at the intervals of different sampling intervals, there are source symbols are generated and there are k number of source symbols. Okay, see, this is where the alphabet, we call it as a source symbol of S, alphabet S. It consists of some k number of symbols. So this is what the source which is generating the symbols at some rate, repeating, that may repeat several times. Or for example, the text we have in this text, the letter A is repeated several times and letter P repeated several times. So that is what the probability. So the probability that at which the letter occurs, at what probability, how many times it is being generated or emitted. So that is called, we call it as an event. We call it as we call it as an event. So that is the event. The event is occurring at some probability. Event is occurring at probability of something pk. So that is what. So based on the probability, we measure the information. Why? Because I'll tell some example. For example, sun rises east. Sun rises east. Sun rises east is a, every day we come across sun rises east without any ambiguity. So that means the sun rises is a certain event, certainty, that event having a certainty. So that is where the certainty and uncertainty. uncertainty. So if that event occurs with a probability 1, that is sure, that is certain. If the event is having some probability less than 1, that is being uncertainty. That means it is something like a surprising event. But in certain event, there is no surprise at all. So sun rises east, there is no information at all. There is no ambiguity. And because it occurs every day with a certainty that probability 1, there is no information at all. So if at all the event is occurring with less than probability of 1, so there is surprise. So that is called uncertainty event will have some information. So that is where the difference between the data and information. So now if that information we measure in terms of uncertainty, if that source symbol is generating with some of sk symbol of s with a k number of symbols, okay, this is with the probability, the all the probability, sum of all the probabilities will be 1. Whatever the number of the symbols occurring with their different probabilities, but the validity of sum of all the probabilities must be equal to 1. So that is what here either probability 1 or 0, there is no surprise and so no information at all. So with the probability 0, there is no event at all. There is probability 1, it's a certain event, no information at all, no surprise at all. If the probability is less than 1, 0 to 1 are ranging, and there is some amount of information. We measure that information based on the probability. Highest probability will have the lowest information. Lowest probability will have the highest information. So that is why that information is taken inversely proportional to that probability, and we take logarithmic of that function, we get the amount of information. So this I has got probability inversely proportional to probability, some ik, and inversely proportional to pk. And we measure that information as taken as the logarithmic function, and that logarithmic function can be the base of that logarithmic, either natural logarithm or some other logarithmic we can prefer. But in this digital transmission, binary as 1 and 0, so that is what 1 and 0, we prefer base 2, base 2. So that is how the logarithmic base 2 can calculate. So now the probability ranging from 0 to 1, so closer to 0, the probability, the information is high. Closer to 1, probability 1, information is less. So that is what information sk is greater than si means the probability of sk, that is called pk, less than pi. So that probability of si event is pi is more than probability of pk, probability of sk of pk, which is less. So that is inversely proportional, that less probable, more information. Now, based on the probability logarithmic function with base 2, we calculate logarithmic base to 1 by probability is the amount of information of that particular event or symbol. So this is what there are k number of symbols. There are k number of symbols. We can get for each symbol that amount of information at what probability that particular symbol is occurring, and the inversely proportional to inverse of that logarithmic function is getting the amount of information. So you can write it as minus of log 2 of Vk. So for example, that that event symbol, for example, Sk is occurring at with a probability of 1 by 2, 1 by 4, and 1 by 4. Okay, this is what S0, S1, S2 with the probability of P0, P1, P2. So we can find out information of S0, okay, can be taken as a logarithmic base 2, 1 by of 2. So that is where logarithmic 2 base 2, this is 1 bit for that symbol. That is the information. So if at all I want to calculate the information of S1, you can take it as logarithmic base 2, 1 by 4. So this is where logarithmic base 2 of 2, that is 4. So this is 4. So this is where 2 square, this is what 2 bits. Similarly, for I information of S2 can be taken as logarithmic of base 2, again 4. This is again 2 bits. So highest probability having a less information of 1 bit, lowest probability having more information 2 bits. So this is what information of each symbol. So sum of all the probabilities must be equal to 1. So if you find the information of each symbol of a given source alphabet, then the average information, what is the average information? We can find out. That is called entropy. So that is the average information. It's a measure of average information per source symbol. That is a entropy. So entropy is nothing but average of information. What is that average information? If you multiply with their probability with each information, you sum all the product, that is called average. So in probability theory, if you want to calculate the average, you can just multiply with the probability of the individual respective event information. So that is what for k number of events, so k number of symbols are there, so that the probability of each symbol Sk occurred with Pk, and entropy average information, the average of all the product of this information and probability. So respective probability. So that is where now we can find out the entropy in this case where the average information of S0 is 1 bit. Earlier information of S1 2 bit. Okay, information of S2 is 2 bit. So what is the average now? We can multiply sum of all probability 1 by 2 into 1 bit. Okay, so that is what sum. So this is where sum of Pk 1 by 4 into 2 bits plus 1 by 4 into 2 bits. So 1 by 2, 1 by 2, 1 by 2. So 1 by 2. This is 1 by 2. 1 by 2. So this is what 1.5 bits per source symbol average. So that is what 1.5 bit average as a whole. But each information will have 1 bit and 2 bits and 2 bit for that source symbol, but average 1.5 bit. That is called entropy. So if at all we look into the problem is given here, that is what 1.5 bits, 3 by 2 bits. So this is what the problem we just come across. And if you observe the properties of entropy, it is uh, ranging from 0 to logarithmic base 2, logarithmic k base 2. So if at all, see the probability is 1, that is the certain event. What is uh, the information, entropy average information? 0. If at all the probabilities are equally probable at the maximum, that is the k number of events equiprobable is the 1 by k. What is the average information entropy? Logarithmic 1 by k of 1 by 1 by k, that is k. So that is what logarithmic k. So that is why this is the maximum 1 by k equiprobable probabilities. This is what probability 1 ranging from 0 to logarithmic k base 2. So this is what the properties we understand. So then what is the information rate? Now in this previous example, the source symbol of the S0, S1, S2 is occurring at the probabilities of 1 by 2, 1 by 4, 1 by 4, then we understand that the entropy average information, okay, average information is sigma, the pk and logarithmic base to 1 by pk for all k. So this is what we got now, okay, 3 by 2 bits or 1.5 bits per symbol, okay. This is the average. Now information rate, if the rate at which R symbols per second, the rate at which R symbols per second is transmitting. Now, what is the entropy? The average information 3 by 2 bits per second. If information, for example, 1000 symbols per second, okay, then we can multiply with that the rate of that symbol rate multiplied with the average information. So that is how the information rate we get, information rate R into the entropy, average information. So then that becomes 1000 multiplied 1000 symbols per second and 1.5 bits per second, 1.5 bits per symbol. Okay. So this is 1000 bits per second. Then this becomes 1500 bits per second. Okay. 1000 symbols per second. Okay. So 1500 bits per second, that is the information rate. That is how we calculate the information rate. If you know how many symbols per second that is being transmitted, and what is the average amount of information, that is what entropy or average amount of information per symbol. So that is what multiply both, you will get the information rate.